All right, so let's welcome our final and guest speaker, Michiko Asano. Here, I think this will be second talk on synesthesia. No, including your plan, maybe third. Maybe this question. Please go ahead.
Thank you. Hello, I'm Michiko Asano from the University of Tokyo. I'm a psychologist, and thank you for having me today. I'm going to talk about grapheme-color synesthesia and its relation to qualia. Synesthesia is a phenomenon where an individual, when processing information in their mind, not only processes that information in a general way, but also experiences types of sensation and cognitive processing that are generally considered irrelevant to that information. For example, in the case of grapheme-color synesthesia, the people with synesthesia, that is synesthetes, experience colors for letters and digits. And there are various kinds of synesthesia, like grapheme-color synesthesia, sound-color synesthesia, number forms, and so on. And the prevalence is generally low. It is about 4 to 5%, and the prevalence for grapheme-color synesthesia is about 1 to 2%. And synesthesia runs in family and develops during childhood. And synesthesia is not an illusion, hallucination, or disease. It is typically not harmful. Let me introduce some main characteristics of grapheme-color or synesthesia in general, and especially of grapheme-color synesthesia. And the first one is consistency. Sorry, I think. Let me quickly. Sorry, excuse me. The first one is consistency. Synesthetes associate consistent colors with graphemes whenever they are asked to do so. And this is an important objective measure of synesthesia, which is essentially a subjective phenomenon. And test-retest consistency has long been regarded as the gold standard for determining the genuineness of synesthesia. These are some examples from of synesthetic colors from 6 synesthetes, and synesthetes 1 to 6. And the top lines show the synesthetic colors for the first test session, and the second line shows the second test, which was took place more than 3 weeks later, the first session, and the third line represents the colors of the third session, which took place more than a half year later. You can see how consistent the synesthetic colors are.
But there are some combinations that seem to be flipping, like white to black, or nothing to.
Some synesthetes says that some graphemes have actually no colors or transparent, and it is difficult to represent the color using the colors on the color palette they use to report their colors.
But the black thing is actually transparent.
I think so, but depends on synesthetes and cases, and sometimes these black letters characters are really black, elicit really black color, or sometimes they don't experience color for that character, or they experience some impression of transparency. And also some synesthetes say that some characters, they know that some characters are achromatic, but they are not sure whether it is white or black, but or transparent. They know that they say it's achromatic.
That doesn't matter with the background. If background is like white, it feels black.
The background doesn't matter.
Transparent but transient.
Yes, yes. They feel or they experience. And
Is they, sorry,
sure. No, go ahead.
they notice the change in colors? Like suddenly, for example, E becomes red.
Mhm.
Before it's black or white, in the case of F and A, six.
Mhm.
Right?
Uh,
How did they feel?
I think in this case, I think this is just the color is somewhat inconsistent or in not low consistency here. So that depends on cases, but I think for this synesthete, I think she said that for her, the hiragana character E doesn't have a strong color.
Like if this color suddenly changes, maybe it feels weird.
But
So,
you mean that the color changes physically, or
yeah, like when in something, suddenly something particular color, we always are red or
yeah.
and it suddenly changes blue or pink with color, then it may feel very strange.
Yeah.
So I just asked.
Yeah, I think it would be strange. That synesthete would feel strange
Yeah.
if their synesthetic color suddenly changes, but it's a rare case.
Yeah.
So, can I ask a question?
Sure.
In this case, many people answer that shows the red color.
Yes.
So I'm very surprised because you said that this is how it goes. The whole sense.
Yeah, the idiosyncrasy.
Yeah.
Yes.
So why did they thought that the art react to the art the program to affect to this?
Yeah, that's a very interesting point. And in Japanese, aka, red is aka, starts with R, but ao is also with R. And well, actually, this is a very universal thing. The first letter of a sequence tends to be red. For English synesthetes, it is the letter A typically elicits the red sensation.
Do re mi fa
Do re mi do, yeah, do does, yes. Number, that's a good question. Well, actually, that the first grapheme red rule doesn't apply, seem to apply to the digits. The first, letter one typically elicits the sensation of a sensation of black or white or not achromatic color. And it is known that letters and graphemes with very, very simple shape tends to be white or black, white. And so that might be because one is white, one tends to be white or black.
That's true. That's true.
Zero is often transparent or light, white or black.
Maybe this. So here one is not red in general.
But some, in general,
Very
yeah. These six synesthetes are Japanese, but one is typically achromatic for synesthetes in other languages, such as English and Spanish. And,
Is there any situation? Is there any another situation where yes and when no, they align like white?
sorry,
If you ask them yes, the two words yes, no,
yes or no?
is there such a situation? For example, 0 and 1, you might expect like yes, no, words yes, no.
And in the case of words, each of the characters can have limited colors and YES and NO, and also that word as a whole can have a color for that word. And I'm not. I don't know. I'm not sure if there's typical colors for the word yes and no, but typically the first character, for the first letter of the word prevails. The color for the first character prevails the entire word color. Can I go back to the slide? Okay. So the consistency and the idiosyncrasy, that means graphemes do not elicit the same color across different individuals. That's the second characteristic of synesthesia. And the third one is automaticity, or should I say involuntary nature. That is, synesthetic colors are automatically or involuntarily elicited by graphemes. And here are some examples. This is for this synesthete, A is not red, but yeah, that depends on synesthete. And I'm just showing you some examples of Grapheme-Color synesthesia. This synesthete also have ordinal linguistic personification synesthesia, that in which they personificate characters, like A is boy, C is pretty nice boy, or something else. Some people have multiple types of synesthesia.
Because I don't really speak or didn't learn German or anything. So I don't know if there is some kind of a theory explaining that some type of language has this gender, right?
Mm-hmm.
Or now.
Yeah.
Are they associated with the kind of specific origin by some theories? Because it's really weird for me to even conceptualize some kind of like that does have always both gender to be like or
cat is girl and a horse is boy and a cat is girl.
Yeah. And then you talk about female cat as a Oh, yeah.
Yeah.
That
I know.
if it comes from the kind of inflation, people probably sensitive to
Mm.
define the rule, then define makes. I don't know.
I'm not sure. I don't think so. As synesthesia often occurs in the grammatical gender is associated with words, not graphemes. And I think grapheme-color synesthesia is basically a phenomenon in which colors and graphemes are associated. And not they also experience colors for synesthetic colors for words, but it's somewhat generalized or transferred from graphemes.
Maybe related questions. If the development of graphics, so 10,000 years ago,
Mm.
is there anything? Is it possible? Maybe,
Yeah, that's an interesting question. And I think in my view, I think synesthesia was born when human beings have to treat some artificial sequences such as letters, graphemes, and musical notes and days and years.
Probably animals to answers.
Yeah, I don't think so, but yeah, that's yeah.
Related more easy question. When the stage one pass.
In person in the developmental process. I will. Okay. I will talk about. I will mention something related to that later. Here's another example. This person has grapheme-color synesthesia along with number form synesthesia. And well, let me quickly introduce you to the Japanese language in case some of you are not familiar with the Japanese language. Japanese language has 3 types of scripts: hiragana, katakana, and kanji. And hiragana, katakana are phonetic scripts, which means that characters of the scripts represent sounds. And kanji is a logographic character script, which means each character has a meaning or meanings. We also use Arabic digits and English alphabet. So Japanese, yeah, yes. And typically, Japanese synesthetes experience colors for most of these characters. I mean, most of these different scripts and characters of scripts. And here's another example. And
Wait. About the color name characters,
yeah,
Midori
Midori.
doesn't do Midori.
This is a very pale green.
And also dye.
Yeah. The very dark orange, reddish dark. Yeah. But
So that can be both, like the color experience from the color world or color things doesn't actually completely coincide with the typical color.
Yeah, well, yeah, actually, typically, meaning has a very strong effects on synesthetic colors. And red is red, green is green. But sometimes say that I I would I have to I want to resist that I know that this letter should be green, but and I feel in some part it is green, but at the same time I don't think this is green. So I yeah I have a conflict inside my inside me. So yeah, I think as I will talk about later, graphemes, synthetic colors can have several sources of colors, like from the sounds, meanings, and sometimes the sources conflict. So the one big question is what determines grapheme color associations in grapheme color synesthesia? And what we have found so far is that hiragana and katakana characters sharing sounds, but not visual shapes, tends to elicit similar colors. Like hiragana a and katakana a tends to elicit very similar colors. I mean, same sound, different shapes, and similar grapheme colors as synesthetic colors. So that suggests that there are very strong effects of sounds in Japanese grapheme colors.
It's also kind of interesting from Steve's perspective, but RA
RA.
some kind of the person
Yeah.
kind of has a product like structure, right?
Yeah, consonants.
Yeah, feels like relation K.
Yes.
Which S has.
Yes.
But it's not true all for others.
Yeah. Yes. Actually, we found that in some synesthetes, there are influence of consonant sounds and vowel sounds separately on synesthetic colors. So the same kagyo and the same group, the characters from the same group, I mean, the characters with the consonant K sound and S sound elicit similar colors respectively. Yeah. Yeah, YM also shows some strong effects of consonant sounds.
Is the experience sound the color same when you produce and so listen?
The
Same character.
You mean the
In this case, they always see.
yeah. It will represent characters visually.
But when they speak,
well, it depends synesthetes, but it is typically the case that grapheme color synesthetes don't experience colors for spoken words and spoken linguistic sounds. When they experience colors only after they think about the graphemes that correspond to the hearing sounds.
they need the visual.
Visual, yes. Visual input or just an imagination of visual grapheme is okay. But
Visually, mediate.
Yeah, visual.
Mediate image.
Yes,
Example,
yes.
like Grapheme-Color device is actually the hint, but the hint is name.
Yeah,
by
name.
the data.
Yeah.
So data mediate can be.
Yes, that's what found by Ito Sensei at the Niigata University.
So in this here, you use a Japanese. Yes, so maybe the other language. Sorry.
Yes, yes, there are some linguistic differences. Yeah,
And maybe this Javan is quite how to say, ordered.
yeah, ordered about structures. Yes, yeah. So I think that's why we found very strong effects of sound.
They colors or non-existent colors.
Yeah, you mean
Completely made up kanji.
okay, so that not like good characters.
Yeah, exactly.
They don't experience colorful characters. They can't read. They don't know.
No color.
No color. Or very faint colors or どうでもいい colors. they describe.
They only feel colors, colors or characters that they understand.
Yes, they can process. Sure. Yes. Yes. Effects of sounds are also observed in the case of kanji characters. In the Japanese language, there are many homophones, that is, characters sharing sounds. And we found that visually and semantically different kanji characters with the same sound are colored similarly. Yeah. And also we found some strong effects of meaning. In this slide, I show the colors for Arabic digits and corresponding kanji numerals. And you can see the colors are very consistent between the two scripts.
So, like long time ago, Ramachandra did the experiment claiming that this kind of number, digit colors, can sometimes faster at finding visual search.
Yeah.
Either because color quantity, right? But what I have been now hearing from you and also Hamada-san, and also Ito-san seems to be converging with that you first need to see,
Yes.
then experience the color.
Yes.
Yeah.
Yes.
Yeah. So that random one thing is never replicated.
Yeah. It is said it has been reported that the color in the Ramachandran experiment type experiment, colors do not pop out, but so that synthetic colors are experienced only after the digits are recognized by the synesthete. But once the digits are recognized, they elicit colors, and that may help the visual search. So then the performance can be facilitated.
Even if it's just after.
So no pop-up, but sometimes the performance and the synthetic colors may facilitate the visual search.
Combination of the search or
The,
facilitation by grouping or something.
yes,
I see.
exactly. Yes. Yeah. And yeah, effects of meaning is strong. Yeah. And in fact, there are so many factors that are known to influence grapheme color associations, sound, meaning, and shape. Like grapheme shape also known to influence synesthetic colors, like similar shape graphemes tend to elicit similar colors. And ordinality, that is positions in a grapheme sequence, also matters. The similar positions in a grapheme sequence like ABC and IU elicit similar related to similar colors. And letter frequency also matters. Higher letter frequency, more saturated colors. Yeah, in English, yes. And also, there is a considerable influence of memory, like colors of childhood toys. So there are many factors. So the relative size of the impact among the factors, including their interrelationships, is unclear. So in our study, we proposed a model that provides a comprehensive explanation of grapheme color association processes. And there are 3 claims. The first one is synesthetic associations are acquired as graphemes are learned in childhood. And linkages between color representation and representation of the grapheme features in some domain are formed before grapheme acquisition in childhood. That is only a hypothetical idea. And the third one is when a grapheme is learned, color representations associated with representations of the grapheme's discriminating features are mapped to the grapheme. I will discuss the third point in detail here. Okay.
I'm unclear about
Yeah. Yeah, like this is the very simple idea is like this is there's no concrete evidence for this, but this is very hypothetical thing. But if we assume that there are some pre-existing linkages between phonemes and colors, the ordinals and colors, and between shapes and colors.
how is that consistent with your original point that synesthesia runs in families?
Runs in family. Well, I think what runs in family is the tendency to connect information in the brain, but not the concrete associations of letters and colors, letters and colors, or phonemes and colors. Even the twin synesthetes do not experience the same color for our given characters. So
one is synesthetes, then the other one is like
it's very highly likely that both of these twins, but it is also reported only one person of a monozygotic twins only one have synesthesia. So there is a genetic factor, but also there is an environmental factor.
I think guiding is I found that the audience, for example, in this next to not one to
Yeah.
the drug or vice comes to, but maybe it is created. UPDM year, big aspects. One is not a number.
One is not a number.
Two is
Hmm?
one is one.
One is one.
Two is the first one. Three is the second. Of course, zero, even one. Very interesting. Because the number, maybe that means that singular and plural has a different kind of categories.
Okay.
And this manipulation for plurals, the part comes to, so maybe a kind of course, it depends maybe how it is. For me, the two is very quite much. But it almost makes sense for me. When I remember, I didn't get why we need to remember this 1 times x, so the times table thing. 1 times 1 is 1 times 2 is 2. It's super stupid. And that's sort of the idea, right? Like unit is really difficult regardless. Many people talks about zero is very similar for the Western culture, but actually one is so maybe in that this hypothesis or how to say for me it's natural because of the not a few people makes two together.
More interesting.
I'm not saying that stronger claim that to see people who are not synesthetic can become synesthetic simply by learning.
No.
That's not. That's not.
Yeah. Oh, not simply simple learning does not always do not lead to synesthesia. Yeah.
So there must be biological.
Some biological genetic factors.
Yeah.
I remember that again, around 2000 or so, John Kahn, somebody else, did this anatomical study of the children or babies, monkeys, and also potentially like humans. The humans are then find that the number of synapses when the ball is, reading a lot, and then as you read fire, it gets more
Pruning, neural pruning.
so the claim at the time was like everyone is up bar.
It's
Is it still
I'm not. Yeah, it is called neonatal synesthesia hypothesis, and that means everybody is synesthetic in childhood, and adult synesthetes are people in whose brain pruning is not sufficiently occurred. And I'm not sure. I don't think it is supported because there are so many linguistic factors there are so many effects of linguistic factors, and that cannot be explained by the very simple neural pruning. Okay, so here we assume that linkages between color representations and representations of features in some domains, such as phonology, ordinals, and shapes, are formed in the brain before grapheme acquisition, and note that some of these representations are tied to a grapheme. In the case of English alphabets, usually one grapheme is associated with several phonological representations. For example, and in the ordinality domain, one grapheme is linked to one ordinal representation. For example, C is the third character. And in the visual shape domain, usually one grapheme is linked to several basic visual features representations because graphemes usually consist of several basic visual features. And when a grapheme is learned, one of the color representations of the grapheme's features is mapped onto the grapheme. And complex correspondences can reduce the influence of that domain on the grapheme color associations. In this example, ordinality should have the greatest impact because there is a simple one-to-one ordinary grapheme mapping. And the color associated with the representation of third, here in this example, yellow, is most likely to be the synesthetic color for the letters. And our model is best characterized by contrasting cases of graphemes of different writing systems, English alphabet and Japanese hiragana. What does the model predict for different types of graphemes? For example, Japanese hiragana and characters. Hiragana characters are phonetic characters which form a sequence just like English alphabet. And in the phonological domain, however, hiragana characters and English alphabet are different. English alphabets have a very complex one-to-many correspondences between grapheme and sounds. But in the case of Japanese hiragana, there is a one-to-one relationship between graphemes and phonemes. One grapheme is associated with one phoneme representation. So, shown is the direct comparison of the cases of English alphabet letters and Japanese hiragana characters. In both cases, there are simple, that is one-to-one relationship correspondences in the ordinal domain, and one-to-many complex shape grapheme correspondences. But in the phonological domain, English alphabets and hiragana characters are different. In the case of English alphabets, a complex one-to-many relationship obtains between graphemes and phonemes. On the other hand, Japanese hiragana characters, there is one-to-one, very simple relationship. This lead us to predict that synesthetic colors for English alphabets are greatly influenced by ordinality, but not by sounds. On the other hand, synesthetic colors for hiragana characters are greatly influenced by sounds and ordinality and less affected by visual shapes. So to test this hypothesis and the validity of the model, we used multiple regression analysis to assess the relative impact of ordinality, sound, visual shape, and grapheme frequency on synesthetic color choice for hiragana characters in the English alphabet. 17 Japanese grapheme colors participated in this study, and all report consistent synesthetic colors for both English alphabet and hiragana characters. In the experiment, the synesthete selected a color corresponding to each of 46 hiragana-based characters and 26 English alphabet called uppercase letters. Thus, we obtained synesthetic colors and submitted the data to subsequent multiple regression analysis. Okay. And in the analysis, we use the method developed by Watson et al. 2012. We explored second-order similarity mappings between differences in synthetic colors of graphemes and differences in values in one domain of grapheme features. So the correlations between differences in synthetic colors of graphemes and differences in values in one domain of grapheme features. And these four dependent measures, values, forms of grapheme were that is ordinal differences between the position in the sequence of two graphemes. Like B is the second character and C is the third character. So the difference is 1. And the ordinality difference between the letter C and B and C is second and third is counted as 1. And the phonological similarity, that it is number of shared consonants and or vowels in names of two graphemes. And visual similarity, that was a subjective similarity ratings, scores, and familiarity differences. That was also from subjective familiarity rating.
So 2 objective and 2 subjective.
Yes. Okay. And here are the results of the multiple regression analysis. The betas reflect the relative unique contribution of each predictors, and larger betas in absolute. Sorry, Euclidean distance in the C colored space. Sorry, thank you.
That's also
Objective, yes. The selected colors by parts. The object, yes, no, the synthetic color distance is very objective. Yes, objective, yes. And the results are larger betas in absolute value indicate that the predictors have greater impact on synthetic color distance. And the statistically significant predictors are shown in red. And as we predicted, synthetic colors for English alphabets were greatly influenced by ordinality, but not by sounds. Whereas synthetic colors for Japanese hiragana characters were greatly influenced by both ordinality and phonology, sounds. And these results are consistent with our prediction. And also some previous studies. So to summarize, English alphabets were greatly influenced by ordinality, but not by sounds. And hiragana characters were greatly influenced by ordinality and sounds.
Can you come up with the model prediction? Why do you think this is expecting by the
okay,
yeah, just yes. But can you explain the reason again? Why you think this does? Reason does based.
And our hypothesis that the simple relationship is sorry, the domains in which there is a simple correspondence between grapheme and the domain, the representation of the domain, have the greatest impact on strong impact on synesthetic color.
Yeah, assumption is one of the assumptions is if yes, and if the one-to-one correspondence is stronger than someone correspondence. If you assumption assume, then you should influence not the influence here one or effects sound. But I'm really doubting that whether when correspondence is one to many, like for me, seeing just like for Japanese, like see, not still or cool. If any other sound comes in mind, like when I look at see. So see is to me just one having.
So you never associate a check or check or color.
Yeah, it's not zero, but once I'm here, like it's actually just if I look at the then to me it's like not cool. Any other sound comes in my mind for us. Yeah, for us Japanese. So maybe for English, native English still it could be different. But, so yeah, as I understand previous studies, this sound effects.
Well, in English, synesthetic sound effect is very weak or almost non. That was shown in the Watson study. This Watson and his colleagues reported that they did a similar analysis with English synesthetic colors data, and they reported there was no impact of phonology on English Grapheme-Color, but there were some effect of shape and orders.
So you clarify. Yes, context.
Yeah. Yeah, and the yes.
So I think it is harmless, but actually, using Euclidean distance as not so much. I think that it is not harmful for results instead of the image. For a new kind of like subjective expressing that maybe more beautiful and clear.
Yeah. If we have
because I think it's a kind of an artificial.
Yeah.
It seems.
Yeah. CIE plus CLAB.
But this was also works, and I think it's not so much.
Yeah.
More, I think it will be better.
Yeah. Yeah.
Yeah, we will get the data.
Okay. Thank you.
But I guess for the publishable on this, will probably also extend like other things are also objective as well, like part of them,
Yeah.
like ordinarity and chronological similarity. And if everything becomes subjective, would it be better or not? That's something I
Yeah. Well, actually, we use these measures because these were available, and also we believe that subjective, not the objective measures, but the subjective similarity similarity matters. And I mean the qualia of the visuals, visual shapes and familiarity and phonology and so on matters in this case. But it was difficult. It is difficult to obtain a subjective similarity of subjective phonological similarity of the letters. So online. Okay. Yeah.
It's like
Yeah.
it's
Yeah. That's a good idea.
Because that part will kind of complete your story all around it, right? Because you say that synesthesia happens after seeing and then understanding its meaning and then you experience things. If that's the case, it's ordinarity or chronological similarity at the level of subjective similarity, subjective ordinarity should impact more on the subjective colors.
Yeah. Yeah.
yeah, and also some kind of psychological decisions. And that is our tendency to classify the phenomena into the digital.
Yeah.
So the colors, it definitely is very continuous on some, but after some kind of ordinary in this stuff. So if you make some discrete kind of order, then I think we factorize to the ordinary. So color and ordinary is quite about primitive of the psychological.
I don't know, maybe I should
Yeah.
speak about that. But maybe let's go.
Sure. So discussion. As the model predicts, the magnitude of impact of each grapheme property differed across two writing systems, English alphabets and hiragana characters, as a function of different linguistic characteristics. And perhaps Grapheme-Color synesthesia can be seen as an association of the structures of the qualia of grapheme features, with such as sounds, shapes, meaning, frequency, with the structure of the qualia of colors. And grapheme learning requires discrimination graphemes. So in the model, we assume that simple corresponding relations between a grapheme and a feature domain representation increases the impact of that feature domain on grapheme color association. Such feature is, in other words, a discriminating feature of the grapheme, in that the feature representation makes the greatest contribution in discriminating that grapheme from others. So synesthetic colors may contribute to grapheme discrimination and learning if in young synesthetes, because they are tied to discriminating features of graphemes. I can stop here.
Yeah, can I so from the viewpoint of the predictive coding, so this model can be explained as based on the variance connection that the character graph into in the English speaking situation, the grapheme consider connection the common. So it means that's the relation of variance. Let's say that the light variance may reduce the weight.
Yes.
So from the report, the very coding, so that is where the result is very decent.
But you know, that's fine as it is, but this is, in a sort of sensory psychology kind of, domain. It's for more consistent, idea of divisive normalization. Or, you know, attention kind of, you know, attention of the divisive normalization. What it means is that if you have lots of things, going on, then the weights are suppressed, you know. But like what, yeah, so under the higher background contrast, things become less, you know, because formalized. But 3D Qualia, I thought this is a concrete example of the 3D Qualia to evolve explanation because you continuously, you know, see the error between what you see. Well, which you know that it should be called like a color, but you see color, and it doesn't minimize this prediction error. What I
the feeling color may reduce the relation between the this is a volume. I don't know how to reach by.
I mean, probably it's possible to like frame in this kind of thing with a 3D framework. It's very flexible. Some way to minimize filtering and at what level or from what viewpoint to minimize some. I don't know.
Yes, yes, synesthesia cannot be used to predict environment, external world.
Yeah. So I think it is related to the cycle choice because without this tendency, we cannot do symbol calculation or calculation. So to get the idea of graphics, you need to have some primitive kind of distributed categorization. Without that, this A and this A is different. So the equivalence question contain. So I think the color and ordinals, maybe ordinals more obvious, that is very special kind of Qualia. It can consider a kind of this. Of course, it is considered color is considered that some Qualia has some kind of this. Category is it is covered in.
You mean the tendency to categorize things is what you're saying as a fact?
Yes, without that tendency, we cannot. I think we cannot obtain the reference. Not for some symbols, because of the phenomenon general things. So I think that this merits or categorizing all quite with local to the error prediction error. So allowing these without allowing these errors, we can obtain the low entropy. So I think it's not so obvious counter example.
I see. Overall, it may be minimizing some.
Yeah, minimize some kind of complex. Without this kind of anyways, you can't do digital kind. So I quite agree with your hypothesis that learning the graphing needs some basis, and the synesthesia is very big. So, and also historical evidence should suggest that the numbers, the figures, come first than other data.
You mean the figures of 2, 3, 5,
Yeah.
up to
History. Of course, it may be that as far as oldest
in the human history.
history 考える結構で
Maybe such a growth about something, but yeah, really? So Egypt comes before Africans?
And
uh,
that development, child,
That's
no,
through evolution or?
evolution, I'm not sure.
but evidence, so as far as we know, the oldest time is now. Like
Ah,
yeah. So it's we got the Chinese character one, secret Chinese character is one.
ah.
And then yeah, this sounds. It is not my idea. I think it is not. Of course, it can incorporated. But as far as the bacteria comes first, then your heart is fully. It's very based.
Yeah.
The stage is for me very much. But the linkage between all the other parts, these are very
Yeah.
primitive basis for this kind of classification. But which comes first or the both what is the linkage is quite mysterious.
Yeah, that's a big mystery. Yes.
But this linkage can differ among visuals. So my question is, can we predict SN colors for some newly learned language, newly learned colors?
Well, the rest on the slide for 42, I don't have, I think we have time for that, but when we learn when we learn new characters, it is known that typically the case that synthetic color are transferred to graphemes learned later from the earlier ones. And such a transfer takes place after only a 10-minute writing exercise. Like this Gragoli font. It is a very ancient European alphabet, and this corresponds to A. And in this way, they ask participants to take place to engage in a drill, like writing 10-minute writing exercise. And after 10 minutes, the colors for the letter A transferred to the new character.
With additional model or regression model, maybe you can predict color before, like before they run something, you first predict color, and then you can check whether this predicted color matches with actually imported colors by.
You mean the very first step of graphemes that is learned in
like a generalization performance of
Yeah.
But
Yeah, this is fun. Experiment.
this one is a sort of training.
yeah, it's
Here,
called
people
yeah,
and A.
yeah, yes, later.
And then that's important. Yeah. Usually you use sort of language, so if they say Korea or
Probably. Well, here, it's like, let's say, you have some kind of color structure here or somebody, and then if you have kind of a data like structure here. I don't know what to do, but
Yeah.
if this one corresponds to this color, and then this one corresponds to this color, can we actually predict this to make this kind of color?
Yeah.
That's a prediction.
More complicated, we can value the degree of association, terms of shapes and sounds, and also meanings. With this model,
From that multiple regression.
is exactly from multiple regression. With this model, we learn free and going.
Yeah.
And then how we actually what get effective. How I think what kind of color graphene for new Korean characters. Maybe we can read.
With this kind of
Yeah.
different way, right?
Exactly.
Yeah.
Yeah.
Mm.
I was kind of thinking like that. So the Pakistan's idea is of linking two structures to make some kind of synesthesia. I thought that when I heard your presentation now, it's kind of good because it's not like a simple one-to-one kind of structure match, but it's this mixture of the structure
Yes.
with some of them have smaller weights, some of them have stronger weights.
Yeah. And it could be different between among individuals. So we customize model for each individual, but in principle we may predict how they fit.
So in that sense, so assumption when you have this A, B, C, D,
Yeah.
F, G, and for this multiplicity of the sound association for C is clear. I mean, C can be or C or something like that. But some of the letters are very clearly one-to-one, right?
Yes.
Then in that case, that particular letter has a very strong weight.
On the weight of phonology. The
Phonological kind of
yeah,
influence.
that could.
So it's not that the one structure's influence is uniformly there, but some of these structures, this part is blurry, but other parts can be strongly affected. Something like that can eventually explain overall.
Yeah, just my point is that sort of more strong variation could be just predict.
But how can we do that? Maybe it's
It's
we don't.
all the letters fine.
But if you do that, then at that point you already associate power.
Yeah. So I want to predict that association for each letter for your family. Maybe relation. And for example, the relation between the moving colors comes like the importance of all. And I'm thinking and wondering why colors and sounds can be the importance of the sound, or maybe the sound color relation is maybe very different color.
Yeah.
But for example, if you do such what's your style, what's your style, and how color, if so then maybe in the modality there is maybe found such a structural resemblance. Then
maybe the linkage height. Check linkage height. Height is can be possible.
No, well, yeah, that's fine. And well, the that side for this is nothing. This is okay. This graphs show the transfer, synthetic color transfer from the first language. In this case, the English, no, the Russian Syriac alphabet to the synthetic second language, which is English. And in this case, some characters transferred via visual similarity, and some other characters color transfers via phonetic knowledge. No, in this case, there was ordinality was not considered. This is a very this is a case study, and they did a very qualitative analysis.
This is something that I think first sort of going on in terms of the possible report online experiment. So you probably assume that ranking of B and C is different by one, right? The A, B, C, and B second, C is second.
Yeah.
But I always get confused between like the order of U and B or S and B. And then when I need to count that, then I need to go A, B, C, D, then I understand which one comes first. So that is consistent with the Weaver's law, like the block compression. Towards the end, is more in this kind of compression.
Yeah.
Towards the end, the order becomes quite unclear.
And many statistics also report that the order and the impression of colors are less clear for the characters in the second half of the alphabetic and hiragana characters.
Okay,
XYZ is somewhat again these are the very last characters. But something like the
Especially this is symbolic. This is not and symbolics subtitles versus determining whether two numbers are which two numbers are higher or lower it becomes increasingly hard as an understand lower, right? But the ratio.
Something like that. And that's the thing that I'm thinking of maybe worse measuring actually. In terms of the subjective.
Subjective order, yes.
We had the probably longest, during the presentation after it was very exciting. Thank you.
Thank you very much. Thank you.